Hi, how are you people? I am Priyanka Singh, if we have not met before, and today I've come up with a new coding problem to discuss with you guys. Here, which is min stack, which you can easily find with LeetCode question number 155. So let's look into the problem. Here we need here this is the question minimum design. We need to design a stack that supports push, pop, top and retrieving the minimum element in constant time. So here what push does for the beginners who are facing stack first time, what push does, it pushes element X onto the stack, and it behaves in a LIFO manner, last in first out, just like a stack, just like a pile of stacks. Next push, it removes the element from the top of the stack, and top, it gets the top element, whichever is present at the topmost position in the stack. And fourth one is get min, which will retrieve the minimum element in the stack. If we look into the problem example here, so this is the min stack. What it says here is your min stack object will be instantiated and called as such. So whenever min stack is performed, it will create a new object for us in the memory, and then push -2, then it outputs with null, push 0 outputs with null, push -3 same, then get minimum. Minimum till now in the stack is -3, hence we will return -3. For pop, it will return nothing and it will just delete the last element which we just inserted. And top, it will return topmost element present in our original stack. Get minimum. So guys, you remember we deleted -3. Now what is the minimum element which is present in the stack, which is -2. So that is what we need to return here. All right. So after understanding this question, I strongly suggest you guys to try it out yourself and then come back here to see the solution. All right. And I mean, this is the way you can learn things. Just by looking into the answers, you can never learn it. So I will explain the question in a better way. This was the problem given by the LeetCode, and here action will be these and output will be these that I just briefed you out in few minutes back. So you can just pause the video and look over it. So here first action was min stack. As I said before, it will create two new stacks for us. One is original stack, another is min stack. Original will carry all the elements whichever are present in the stack, and min stack will track down the minimum element which is present in the original stack, so that we can give minimum value to the user in constant time. Another action was push -2. We have pushed -2 in the original stack as well as min stack because there was nothing present in min stack earlier. So we can consider this is the minimum element till now present in our original stack. Now we pushed 0, then for 0, so we pushed it in our original stack as well as no. Then we need to make a check if this is the number which is smallest in the entire original stack. No, it is not. Then we won't push it in min stack. Then we will push -3. For -3, we pushed it in original stack and then checked if it is the minimum element present in the stack right now. Yeah, it is. Then we pushed it in min stack. Then action is get minimum. We can easily grab it out from minimum stack, which is topmost element present in min stack. and then pop. In that case, we popped from original stack and then checked if there was a case we added -3 in minimum stack as well. We have to make a check for it. If it is present, then delete from there as well. And then it asks for topmost element, which we can just pick from the original stack. Then git minimum. Now whatever elements are present in the original stack and minimum stack, so we can easily grab it out from minimum stack. All right, now we will look into how we can solve it in terms of code. So as I said you before, we will have two stacks here, and this is a wrapper of integer because it accepts wrapper of int, not int, which is integer. So here we will take stack and min stack, right? We need to initialize here same for this. Then we will push it in stack, and then we will check if stack.push, if we will check if x is smaller than min stack.peak. If it is, then we need to push in min stack as well. Then comes delete. So we will delete it, but we need to also check if it is present in min stack or not. Then we need to save it somewhere and make a check. Accordingly, we will delete it. If this is equal to min stack.p, then min stack.top, right? For top, we can so stack. From stack, we need to return for this, return min stack. From min stack, we need to return. So that is pretty simple, these last two. Okay, so here is a corner case we need to handle. If min stack is empty, in that case, we will just push the very first element in min stack, considering it is the minimum element present till now. Let's submit it. So empty stack exception, line number 27. Okay, so here what's happening, 0, 1, 0, 2, 0 is the number which came twice, but we counted it once in minimum stack. Hence, there is a case we need to handle when there is a new element which is coming and we are already having it in a minimum stack as a minimum stack. So as soon as we popped 0, it deleted a single 0 we were having in a minimum stack. Hence we need to delete it from. Hence we delete it from there, and it made empty our minimum stack. Hence, here is the case we need to handle. We will be, if a new element is coming in our stack and it is minimum and it is repeating, then we need to insert it again, because next time we will be popping that element, there should be two presence of it. Let's check how it works. It's submitted. It got submitted. Now, and here is the code snippet for the same. I'll add link to it in a description box, and let me know how did you guys like the video in comment section, and do like, share and subscribe my channel.